Okay, here we go. Okay. So we have this. All right. And again, this was something also in statistics. We like to study groups of people and collect data about it. And again, generally, how do I say this? Right. The population, this is the actual definition. That is the group that you're studying. You know, the group, the entire group of objects or people you're interested in a statistical study. You know, here's an example I gave. I think I might have given this last time as well. You know, we might wonder, for instance, how many hours per week, you know, a typical college student does. That is, a typical SUNY Oneonta college student does. Notice I had to clarify myself because we have to be specific about the population. So we have to be specific. I mean, if you instead of saying SUNY Oneonta college student, you just say college student, well, that's kind of general. You know, if you were to go to college students here at SUNY Oneonta and college students at, I don't know, Harvard, or college students at the university at Buffalo, you know, you're probably going to get very different answers for how many hours a week they spend reading. So you do have to be very specific with your population. And even then, you have to be careful when you look at the SUNY Oneonta students. You know, because for instance, if you're only asking students who are majoring in a field like philosophy or history, you're going to get very different. You're going to get very different answers than if you were to only ask physics majors or math majors. You know, every major has a different amount of required reading, so to say. So you do have to be very specific is what I'm saying. And even from here, this also brings up the idea that with your sample, you have to make sure you include enough, and you have to make sure you include enough people. That is, you have to choose your sample correctly so that it's representative of the population. So you don't want to have a sample full of only, you know, students majoring in the humanities, if you're answering this question. And you don't want to have only seniors, for instance, in it. You want to make sure it's representative of the whole population. And this brings us to parameters. Basically, a parameter, okay, that's a value that you calculate using the data from the population, from the entire population. You know, for instance, going back to that example I just said with the SUNY Oneonta college students, okay, you know, you might consider every single student in the population. So then you have a parameter. When you're dealing with the sample, though, as down here, that's when you have what's called a statistic. You know, however we form our sample, if we ask every person there how many hours a week they read, that would be a statistic because you're getting your data from a sample. So parameter, sample. A census also, that's just a survey, as it says there, a survey of the entire population. That's what that is. I mean, you could use a census, again, to ask everyone in the SUNY Oneonta population how much reading they do, but, you know, that would be very time-consuming. Now, you do have to be careful when forming a sample, though, because as I said before, you want to make sure your sample is representative of the population. You know, I said that already. I said it here also. I say it here also, I mean. Let me just say also, these are just some examples I just, you know, got from the book. I figured it wouldn't hurt to go through them. You know, for instance, let's say we wanted to determine the average length of trout in a lake. So what researchers, and let's say what they decide to do, they decide to catch, you know, 20 fish and measure their length. So the question here is, what's the sample and population? Well, I have the answer there, but even if I didn't, you should be able to see what the answer is. The population is all the trout in the lake. That's what they're analyzing. The 20 they catch is a sample. Right? They're not measuring every single fish in that lake. They're catching only 20. Now, how do they know just catching 20 is enough? That I don't know. But that's their sample. Here's another one. The college reports that the average age of their students happens to be 28 years old. So is that a statistic or a parameter? So again, this I got from the book, and they're saying, which I agree with, it's a parameter. Mostly because the college does have the age of all of their students. You know, they have information about each student, right? You know, where you're from, what your major is, that kind of thing, and their age as well. So it would make sense to say that's a parameter. Statistic, remember, is data about a sample. Parameter is about the whole population. That's good. That's good. Okay. Now, again, I just said, how do we know? So how do you actually make a sample? Well, that's where things can get a little bit tricky. So we have these sampling methods. Basically, once you identify the population, right, you want to somehow obtain a sample. You can't just do whatever you want, though, as I said before. So you can't just go up to, you can't just choose anyone that you want to sample that you want to. It's not about convenience. You have to make sure it's representative of the population. That's the whole idea. So again, going back to that college example, if we want to know how many hours a week that SUNY Oneonta students read, how many hours a week they read. We can't just go up to, we can't just ask students that are humanities majors. We can't just stand outside of Fitzell and ask students as they go in and come out of the building. That might be convenient, but it's not the best method, though. We want to get a representative of the whole population. Basically, what we're trying to do is to avoid sampling bias. That's when the sample is not representative of the population. Mostly because what happens is some members of the I think I might have messed up a definition. Sampling bias occurs when some members of the population have a smaller likelihood of being included in the sample than other members do. So I wrote it here as well, but if we stood outside of Fitzell and just asked students there, how many hours a week do they read? Assuming they all tell the truth and assuming they all answer, that would still be sampling bias. Not every student has a class in Fitzell Hall. Certain students do, for instance, if they're math majors or computer science majors, because that's where those majors are located. What about the other buildings where the other majors are located? Like art classes, for instance, or I don't know, music classes. I don't think those are in Fitzell, as far as I know. So basically, what I'm saying here is you have to be careful to avoid sampling bias. Okay, so how do we avoid that? Well, there are different methods we can use. There are different ways of getting a sample. One is here, using what's called a simple random sample. So in other words, we want our sample to be what's called a simple random sample. That's one way to ensure we have a good sample. Basically there, as I wrote here, every member of the population has an equal probability of being chosen. The first definition I got from the textbook, but I wrote this also from this website. I thought this website was a little bit better. The definition, basically with a simple random sample, everyone in the population is equally likely to be in the sample. So for instance, what you can do, for instance, is let's say there were 10,000 students in SUNY Oneonta. If you had a list of them all, let's say, you could use a random number generator to choose your sample. And everyone is equally likely. Or somehow if you had everyone's name on a piece of paper. Actually, no, let me check that. If everyone's name was on a separate piece of paper, that's better. You put, somehow put the papers in a big hat or a really big bin, I guess. And then you choose a number at random. And you would have a simple random sample. As it says here, it's theoretically, it's easy to do, but it turns out it's very hard to implement.